So now we're familiar with the lens law. Let's apply it to a two lenses system. So we have image first object, and it was beyond the focal length. So it will give us an virtual image, and then the virtual image will go through the second lens and give us a real image, second image. That is pretty much how the eye works, because we use the magnified glasses, and we will try to see that image. And of course, we need a real image on our eyes, in the eyes of the projection to the eyeball. So that's basically our eyeball, and this will be the projection image on our eyeball that give us the information. So there is some strategy because it's rather complicated. So here's the strategy. If the image is real, then the eye, you can think eye as a distance to the lens. If it's imaginary or virtual, then the eye is negative of the distance, which is a negative number. So you can try to find the relationship, which I'm gonna explain in the future. Imagine that the image is real. For instance, you got the first image, an virtual image, right? So you can imagine the first image as a real image, and then we will obviously have an I1 prime like this, and then the object distance between the second object and the second lens will be O2. We know the distance between the first lens and the second lens is L. Then we will end up getting a relationship like L equals to I1 plus O2. That's how we imagine the image is real and to try to find the relationship. And use the lens equations to calculate everything. But keep the sign. Don't make, we end up having a virtual image, let me just make it positive. No, keep the sign, keep the negative sign, and then just keep on going with the equations. So we have the three equations, and we have three unknowns. So that's the solvable equations we can solve. Solve that, ended up getting the I2. So yeah, that's rather complicated, so please think through that, and maybe you can replay it and think about how to apply those steps to this scenario.